balancing a redox reaction using half reaction method. Here I will be explaining this method with the help of an example. There are total 6 steps in NCERT. There are 7 steps. The last step is just to verify that everything is fine. You don't need to remember that. So in total 6 steps. The first step is write the unbalanced equation in ionic form. This is the example I will be considering to explain all the 6 steps, and this is in acidic medium. The medium will change one step to balance the reaction. So you need to specifically focus on whether it is acidic medium or basic medium. Second step is to separate the equation into half reactions. Half reactions means oxidation half and reduction half. So if you see here, iron here and iron here, oxidation state is changing from +2 to +3. It means this is oxidation half. So I will say this is oxidation half. Similarly, the reduction half, if you consider chromium oxidation state here and chromium oxidation state here. First, assuming chromium oxidation state here is X, then it will be 2X plus 7 oxygen oxidation state -2 equals to total charge on dichromate ion, that is -2. So you will say 2X is equal to 7 into 2, 14 on the other side, and -2, that is 12. So X you will get 6. Here oxidation state of chromium is +6, and here obviously it is +3. It is reduction half. +6 to +3 oxidation state reducing. So this is reduction half. So you will separate the whole equation into 2 half reactions. The first one oxidation half, because the oxidation state is increasing. This is oxidation half. The other one reduction half, because the oxidation state is decreasing. After that, the third step. The third step is to balance the evident ones. If you remember, if you have seen my video of oxidation number method, that method has this hidden rule. NCERT has not mentioned it as a separate rule. So I told you, you need to remember, balance the evident ones. This is the same rule here as step 3. Balance the atoms other than oxygen and hydrogen in each half reaction individually. So if you see, iron is already balanced. In oxidation half, iron is balanced. We don't need to bother about it. This is other than oxygen and hydrogen I am talking about, other than oxygen and hydrogen. But in reduction half, if we see, here we have 2 chromiums. On right hand side, we have only 1 chromium. So we need to place 2 here. Now chromiums are balanced on both sides. Step 3, balance atoms other than oxygen and hydrogen. Next, step 4, very important step here. For reactions occurring in acidic medium, balance oxygen by adding H2O and balance hydrogen by adding H plus ions. In acidic medium, you will stop here. I will tell you what you need to do in basic medium. In acidic medium, you will balance the oxygen by adding H2O on appropriate side, and you will balance hydrogen by adding H plus on appropriate side. Hydrogen and oxygen we did not balance in step 3, so that's why it's step 4 for that. So if we see here, we don't have oxygen or hydrogen. We don't need to bother about the oxidation half here, but we do have oxygens in dichromate ion, and there are 7 oxygens here. So if we see here 7 oxygens, we need to add 7 H2O on right hand side. Now we have 7 oxygens on both sides. Now we need to balance the hydrogen. To balance hydrogen, we need 14 hydrogens on the left hand side. We already have 14 hydrogens on right hand side, so we will add 14 hydrogens on left hand side, 14 H plus on left hand side. Fourth step complete. But if the reaction occurs in basic medium, then what we do? Remember, up to here it will be same, but after that we will add those many OH ions on both sides as there are hydrogen ions. So if it would have been in basic medium, then what we will do, we will add 14 OH minus on left hand side and 14 OH minus on right hand side. On left hand side, in this case, 14 H plus and 14 OH minus will give us 14 H2O and 7 H2O on right hand side. So effectively we will be having 7 H2O on left hand side, 14 minus 7 here. But in this case, we don't need to bother about that. This is acidic medium. We don't need to add OH minus on both sides. That is just for your information. Next, fifth step, balance the charges. Remember, in oxidation number method, fourth step was balance the charges. Here, fifth step is balance the charges. How to balance the charges? Here, the method is slightly different than oxidation number method. Here, the charges are balanced by electrons. Sometimes students get confused because we are using H plus here as well. In case of oxidation number method, H plus was used to balance the charge, or OH minus was used to balance the charge. But in half reaction method, always remember H plus will be used to balance hydrogen. After that, depending on whether it is basic medium or not, you will add OH minus on both sides if required. In case of half reaction method, to balance the charges, we will be using electrons on appropriate side. If you see in oxidation half, we have +2 on left hand side and +3 charge on right hand side. It means I need to add one negative electron on right hand side. So I will have -1 here. Total +3 - 1 will give me +2. Now on both sides I will be having +2. So this is the way to balance the charges. I will balance the charge for oxidation half by adding one electron on right hand side. I have +2 charge on left hand side. I have +3 - 1, that is +2 on right hand side. Both charges balanced. In case of reduction half, I need to calculate how many charges on left hand side and right hand side are there. On left hand side, if you see, -2 charge, and here +14 charge. 14 hydrogen ions. So total charge on left hand side I have +12. 14 - 2 +12. On right hand side here I have 2 × 3, that is +6 charge, and water molecule is neutral. It means on left hand side I have +12, on right hand side I have +6. It means I need to add 6 electrons on left hand side. So if I will add 6 electrons on left hand side, this will give me -6 charge, -6 electron, negative charge, -6. Then +12 and -6 will give me +6. Now on both sides I have +6 charge. So it means to balance the charges in reduction half here, I will add 6 electrons on left hand side. After that, as part of same step, step 5, I will equate the number of electrons in oxidation half and reduction half. Here I have 1 electron on right hand side, and here I have 6 electrons on left hand side. And this is something I would advise you to remember, that in oxidation half you will have electrons on right hand side. In reduction half you will have electrons on left hand side always, because oxidation is loss of electron. Loss of electron is oxidation. Gaining electrons is reduction. You can understand it from one example as well. Chlorine. When chlorine, say it is gaseous atom, it gets converted to chloride ion. It will gain 1 electron to get converted to chloride ion, and it will attain noble gas configuration argon. Now understand whether it is oxidation or reduction. It is reduction because oxidation state here, chlorine, free elemental state 0, and here -1 the charge. Reduction in oxidation state. It means gaining the electron is reduction. So very important point, oxidation will have electron on right hand side, reduction will have electron on left hand side in all cases. Remember it so that you don't make mistake. Now to equate the electrons in both cases, you actually need to multiply the oxidation half by 6. If you multiply oxidation half by 6, you will have 6 electrons here. Obviously at the same time you will have 6 Fe2 plus and 6 Fe3 plus as well. So when you multiply the oxidation half by 6, you will have 6 Fe2 plus gives you 6 Fe3 plus 6 electrons. Now you have in oxidation half 6 electrons on right hand side, in reduction half 6 electrons on left hand side. Why we are doing it? We are doing it because in the second step we had split the equation in 2 halves, oxidation half and reduction half. In the last step we will be combining these halves to get the net equation. So when we add these two, we should have these cancelled, and these will get cancelled only if they are equal. Now add the 2 half reactions to achieve the overall reaction. So we got these 2 reactions after equating the electrons. Add these 2 and we will get the final balanced equation. You have 6 iron here, you have 6 iron here, you have 2 chromium, you have 2 chromium, you have 7 oxygen, you have 7 oxygens, you have 14 hydrogens, you have 14 hydrogens. Everything is balanced, and that is the answer.